بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Dear student, good afternoon. Today inshallah we're gonna revise chemistry for grade 10 advanced. إن شاء الله اليوم سنقوم بشرح ومراجعة هيكل كيمياء عاشر متقدم. السلام عليكم ورحمة الله. معكم المعلمة نهام محمد جمال عمار من مدرسة الرؤية الحلقة الثانية والثالثة. سنقوم اليوم بالشرح. بسم الله توكلنا على الله. نبدأ. يلا dear students, let's start. We're gonna start today with the EOT for grade 10, and it started with the gases. We have 3 units and 25 learning objective, and we're gonna cover them all inshallah. طيب. So the first learning objective is the gas, and what is the gas? Gas is one of the state of matter, and according to the kinetic theory, there is assumption of kinetic theory. What is the kinetic theory? It is a theory that describes the behavior of matter according to size, motion, and energy. Type. According to this kinetic theory, the gas particles are very small. According to the size, it is very small, and it will fill all the space of the container. According to motion, gas particles move randomly, freely, in all directions and in straight lines. When they collide with each other and collide with the wall of the container, they collide in elastic collision. Elastic collision means there is conserved of kinetic energy, means kinetic energy is not wasted. So kinetic energy for the two particles is the same, the total kinetic energy, it doesn't change, no wasted kinetic energy. This is how to calculate the kinetic energy, half mv squared. M represent the mass, v represent the velocity. And how to measure this kinetic energy? Using temperature. Temperature is a measure of the average kinetic energy. So these are the assumptions of the kinetic theory and how we describe gas particle in relation of size, motion, and arrangement of particle and energy. طبعا it said that there is very weak attraction force between the particles, and the spaces between particles are very empty space, يعني it will fill the empty space in the container. Gas can diffuse, and diffusion is different than effusion. Diffusion means when two materials go through each other, but effusion means when the gas coming out of a small hole or a small opening. The rate of effusion, of course, it depends on the molar mass. The smaller the molar mass means the gas is light. So when the gas is lighter, the rate of effusion will be more. So it will diffuse more. So we're gonna say that Graham's law says that the rate of effusion is, this is how we say proportional. And we put 1 over, this is how we say inversely proportional. Okay, so that is how we represent inversely proportional. So the rate of effusion is inversely proportional with the square root of molar mass. Okay, so we have Graham's law, and we now go to answer some kinds of questions. How to get the rate of diffusion of two gases? It will be rate of gas A divided by rate of gas B equal to the square root, but because it is inversely proportional with the molar mass of gas B divided by molar mass with gas A. So please, this is a tip, exam tips, one of the exam tips. Don't forget to cross them. Molar mass of B divided by molar mass of gas A. طيب. you have in your book these 3 questions and the challenging question. Let's Bismillah and answer them. This is how we answer the first one. The question says, calculate the rate of effusion of nitrogen, N2 and neon. So we're gonna say that the rate of effusion of gas N2, which is nitrogen, divided by neon, okay, equals to, don't forget to get it cross. So molar mass of neon divided by molar mass of nitrogen, square root of molar mass of neon divided by molar mass of nitrogen. From the periodic table, we can get the molar mass of neon, and we can calculate the molar mass of nitrogen. Don't forget that nitrogen is N2. That means 2 should be multiplied by the atomic mass. And then طبعا rate of nitrogen divided by rate of neon equal to square root of the molar mass of neon divided by nitrogen. Don't forget to switch or make this cross, okay? And then by calculator you can easily get the answer. Number 2, they want you to calculate the rate of effusion of or diffusion of carbon monoxide and carbon dioxide. So carbon monoxide and carbon dioxide, yes, I will not forget to shift like this or make the cross. So it will be square root of molar mass of carbon dioxide divided by molar mass of carbon monoxide. طبعا from the periodic table we can understand the atomic mass of the carbon 1, it is only 1, so and it times 12. Oxygen طبعا in carbon dioxide we have 2 carbon of oxygen, so it will be 2 times 16, and then we're gonna add them. طبعا carbon monoxide is only 1 times 12 and 1 times 16, and then we're gonna add them. This is how to calculate the molar mass. I believe you took it in last term, and I believe that you're still remembering it. طبعا the square root of 44 divided by 28, and from the calculator you can get the final answer. The challenging question, let us read it together. Challenging question says, what is the rate of effusion of gas that has molar mass twice the gas that has rate of 3.6. يعني I have rate of gas X which I don't know, but what I know is its molar mass is twice, means double, means multiply by 2. The other gas which has rate 3.6, and I will give طبعا the molar mass for it 1. I will suppose it is 1. Okay, so easily I gonna write rate X divided by 3.6 equals to, تمام, equals to square root, and then yes you're gonna make the cross, يعني here 1 وhere 2. From the calculator, if you gonna calculate the square root of half, it will be 0.7. Just simple multiplication because you just rearrange the formula. So rate X will be equal 3.6 times 0.7, and the answer will be 2.5. So the rate of gas X, rate of effusion of gas X, which we don't know what is gas X, but that will be the rate of effusion of it, which is 2.5. Okay, we have finished this learning objective, and we have finished the kinetic theory learning objective. Going back to the book, the next learning objective is to know how to convert between units. Before converting between units, let me explain what do you see in front of you. Before converting between units, you have to know what is pressure. Pressure is, for example, solid, it is force divided by area, يعني force applied to a certain area. So it is force divided by area. This can be calculating using a unit called Pascal, PA, which is Pascal. For any unit, joule, watt, gram, meter, there is the unit and the kilometer. صح؟ كيلومتر كيلومتر، gram kilogram. Pascal also there is kilopascal. And how to convert from the Pascal to kilopascal? Easy. You will just, if you convert from kilopascal to Pascal, you will just multiply by 1000. If you convert from Pascal to kilopascal, you divide by 1000. يعني the kilopascal contains 1000 Pascal. خلاص, that is easy. But there are another 2 units to calculate the pressure, which is, one of them is called atmospheric pressure and one of them is called millimeter mercury. What are they? This is called barometer. This in front of you, what you see now in the monitor, is called barometer. And what is the barometer? It's an apparatus to measure the atmospheric pressure. طيب, how it will measure the atmospheric pressure? Because there is a tube. In this tube, it is filled with mercury, and there is a container of mercury. If this tube will be set upside down like this, so of course, the mercury will start to fall down, leaving behind vacuum. No air in the test tube. It is only vacuum. Okay. Until it will stop. Stop means there is a rule in fluid, generally fluid, whatever it is, liquid or gas. If liquid is in the same level, that means they have the same pressure. That means the point A here have the same pressure of point B, because it stop falling down. If there is difference in pressure, the liquid will keep moving either from the tube to the container or from the container to the tube. But because there is no difference in pressure, so it stop moving, nothing to move. So what is happening here is the pressure at point A is equal to the pressure at point B. But what is the pressure at point A? It is the atmospheric pressure, which is look, ATM. So ATM means atmospheric pressure. But what is the pressure at point B? It is the pressure due to mercury. If I want to calculate it, it will be the density of the mercury times the gravity times the height of the mercury. That is how we calculate the pressure of liquid. Okay. But I don't want to calculate it. I will just calculate this H, this height of mercury, and we found that 1 atmospheric pressure always equal to 760 millimeter mercury. So according to what I'm saying, we have different units of pressure. This is to memorize. You have to memorize this table. But I think after my explanation, now you know what is the kilopascal, what is the millimeter mercury, and torr is 760 also, and what is the atmospheric pressure. And from this, you can understand that 1 atmospheric pressure equal to 760 millimeter mercury. That is how we represented millimeter mercury. Okay? And equal to 101.3 kilopascal and equal to 760 torr. You have to memorize this table. Okay? So this is to memorize. Type. The last learning objective in this unit, and then we're going to move to the other unit. The last learning objective is to know Dalton law. طيب, what is Dalton law? Dalton says that if we have mixture of gases And to calculate the total pressure of this mixture, we can just add total pressure will be partial pressure for gas A plus partial pressure for gas B plus partial pressure for gas C, and so on. So simply all the question had exactly the same idea. All. If you have a partial pressure of gas in the mixture of hydrogen and helium, if the total is 600, يعني the pressure for helium plus the pressure of hydrogen, it should be 600. Type. If the partial pressure of helium is 439, how to calculate the pressure of hydrogen? You will just simply subtract the total minus the helium. So 600 minus 439, and you get the result. طبعا the result should be with the same unit. Here you will not convert. Here you're gonna use the same unit, which is millimeter mercury, because it is millimeter mercury in the question. Okay. Number two, it is I will answer with you that challenging question, because actually 5 and 6, all of them have the same idea. You're gonna just, to get the total, you're gonna add. To get one of them, you're gonna subtract. طب what is the challenging question? Air is a mixture. We all know that air is a mixture of gases, and the nitrogen is the most abundant gas, which is 78% of the nitrogen. 21% is oxygen, and 1% is argon. Okay. And they give you the total atmospheric pressure for the mixture of gases, which is air. They want the partial pressure for each one. This is very easy. It is simple percentage. The total pressure for all of this mixture is a 760 millimeter mercury. The nitrogen 78%. Yep, 78, you're gonna convert it into decimal, because 78% meaning 78 divided by 100. So it is 0.78 times 760, and get the answer. Millimeter mercury. Number two, 21% means 0.21 times 760, and get the answer. Argon 1 means 0.01 times 760, and get the answer. You should check your answer. How? By adding all of these together, and the answer should be equal to 760, because that is the total pressure for all of the gas mixture. Okay? Done? That was the challenging question. In unit number 1, we only have small part. خلاص, we go through this, and we go through this, and we go through this, and this is important. This they're gonna say for you in the flask, if there is sulfuric acid, H2SO4 react with zinc, so it will produce hydrogen. Of course, it will produce hydrogen. You're gonna take acid next year in details, and acid reacts with the metal to produce hydrogen. Okay, anyway, you're gonna take it next term, inshallah, in details. So by producing hydrogen, now there is a mixture of hydrogen and water vapor. Okay. Can you calculate the partial pressure of the hydrogen? Of course. Give me the pressure of the water vapor and give me the total pressure, and I will just subtract them easily. Here in the book they said that the water vapor is 2.3 kilopascal. So by subtracting 100 minus 2.3 kilopascal, you will just get the hydrogen easily. Okay? By this, alhamdulillah, we have finished unit 1. خلاص, we can go to another learning objective, and the other learning objective will be the gas law. According to the gas law, let me explain and then answer the questions. Type. This is the gas law. What is the gas law? Gas law represents the relationship between three variables, which is pressure, volume, and temperature. So, gas law represents the relationship between pressure, volume, and temperature. The relationship between pressure and volume in a constant temperature is called Paul's law. The relationship between volume and temperature in a constant pressure called Charles' law. The relationship between pressure and temperature in constant volume called Gay-Lussac law. Type. How to know what is the relationship between them? Type. Let's explain why there is a pressure exerted due to gas. طبعا the gas, we said the particles are moving randomly and collide with the wall of the container. While it collides with the wall of the container, it means it will produce a force. This force will produce a pressure. That is why there is a pressure exerted due to gases, particles. Okay. By decreasing the volume, what do you think? This volume decrease, what do you think? Of course, there will be more frequently collision. This will increase the pressure. So the pressure and the volume are inversely proportional with each other. How to represent inversely proportional? We represent inversely proportional like this, what you see here. That is how to represent inversely proportional. And that is called Paul's law. And this is P multiplied by V equal to constant. P represent pressure, V represent volume. So P1 V1 equal to P2 V2. Okay, excellent. This is the law. And this is how to represent it graphically, because they are inversely proportional. Pressure and volume are inversely proportional, but in a constant temperature. Pressure increase, so I gonna compress the gas, so the volume decrease. Simply, it is that simple. Okay, so Paul's law says P1 V1 equal to P2 V2. Okay, type. What about Charles' law? Charles' law represents the relationship between volume and temperature. What's gonna happen if the temperature increase? If the temperature increase, the volume will be increased as well. Okay, if the volume will be increased as well, why? Because the kinetic energy increase. So pay attention to this part. Kinetic energy increase, so the particle will move further away, so the spaces will be more, so the volume will be more, it will fill more space, so the pressure, the volume increase. So the volume and the temperature are directly proportional with each other, and that is how we represent the directly proportional, and that is how we represent it graphically. But there are two conditions. One of them is the temperature should be measured in Kelvin, and the other condition is the pressure should be constant. So I can use Charles' law, which is V1 over T1 equal to V2 over T2 in two cases. Number one, the temperature is Kelvin, measured by Kelvin. And number two, the pressure is constant. Type. Let's go to Gay-Lussac law, the third law, which represents the relationship between pressure and temperature in constant volume. Type. If the temperature increase, kinetic energy increase, collision increase of the particle, so of course pressure increase. So there is a relationship between pressure and temperature. Okay, so pressure and temperature is directly proportional. That is perfect. That is perfect. But pay attention to this part. Let me come here. Let me erase it and try to again draw it with you. This is the relationship. This is pressure and this is temperature measured by Celsius, and this is the origin, which is 0, 0. If you draw a relationship, it will be like this. A straight line, linear relationship, yes, but it is not directly. Why it is not directly? Because to say it is directly proportional, the line should be straight line passing through the origin. But here it doesn't pass through the origin. Why? Because at 0 Celsius degree, the particle of gases move, there is kinetic energy, there is collision, there is pressure. So it is not 0. Okay, so what we have to do now? Let's decrease the temperature more, so the pressure will be decreased more. Decrease the temperature, so the pressure will decrease until we reach to a point that we called it absolute 0. This absolute 0, it is equal to minus 273 Celsius degree. And it is actually, wait a minute, let me use a ruler better to make it good line. Okay, so this is absolute 0. In this absolute 0, the pressure seems to be 0. The kinetic energy is very, very, very low. The particle seems not colliding. So this is absolute 0. It happens at minus 273, and there is a new scale which is called Kelvin scale. And minus 273 Celsius equal to 0 Kelvin. 0 Kelvin degree. How to convert? Now, if you look to this relationship, okay, so this is straight line passing through the origin, because actually that is 0 Kelvin and 0 pressure. Yani yes, it is 0, 0. 0 Kelvin. We're going to take now temperature with Kelvin, not Celsius. So yes, now actually it is a straight line passing through the origin. So I can say now that pressure directly proportional with temperature, but measured with Kelvin degree. So this is Gay-Lussac law. It should be temperature measured with Kelvin degree. So to use Gay-Lussac and Charles and ideal gas law and combined gas, all of these gases, you have to convert from Celsius to Kelvin. And this is the formula that we're gonna use, P1 over T1 equal to P2 over T2. How to convert from Celsius to Kelvin? Here we're gonna convert from Celsius to Kelvin by adding 273. طب how to convert from Kelvin to Celsius? Subtracting 273. خلاص? Okay, let's go to our questions. The last thing is the combined gas. It combines the three variables, all the three variables together, which is pressure, volume, and temperature. P1 V1 divided by T1 equal to P2 V2 divided by T2. Let's go and answer from each law one example. In this law, I'm gonna answer the first one and the challenging one. Okay, the first one says the volume of a gas 99 kilopascal, and the volume it fill is the pressure is 99 kilopascal, and the volume is 300 milliliter. The pressure too, it is increased to 188 kilopascal, and they're gonna ask you about the new volume. Simple, just substitution. You're gonna put your formula, substitute P1 V1 equal to P2 V2, and to calculate the V2 you have to multiplied 99 times 300 divided by 188. The unit should be the same unit. We will not convert here. We're gonna use the same unit exactly. Okay. Now, type. Okay. This is the first question. Let's go to the challenging question. Why? Read with me. The challenging question says, the cylinder fitted with a piston occupies 145.7 milliliter at 1.08 atmospheric pressure. Okay. What is the new volume of the piston if the piston depressed and increasing the pressure by 25%? So here I have P1, yes, and I have V1, yes, but I don't have P2 because they said it is increasing by 25%. So step 1, I have to calculate P2. How? They said increase. If I have to add P1, the initial pressure, plus the initial pressure multiplied by 25%, which is 0.25. Whenever you see decimal, we're gonna do it to calculate it. You have to make, whenever you see percentage, you have to do it per decimal. So calculate, yalla. We're gonna calculate. It will be 1.35. خلاص. You have P1, P2, you have V1. Simple calculation to calculate V2. Type. You have the freedom to either rearrange like this, then substitute, or substitute first, then rearrange. They will give the same result, of course. It is according to your comfort, which one you are comfortable with more. Okay. Type. Next, this is Powell's law, and خلاص we answer Powell's law. Let's go to Charles' law. Charles' law is the relation between volume and temperature. This is the formula. طيب, the first question is just easy. It is simple. All of the questions are the same idea. Let's answer question number 5, which is the temperature is 89 as Celsius. I want to answer 5 because they give you in Celsius. In 4, خلاص, it is easy. They give you in Kelvin already. But here I want to convert. Again, how to convert from Celsius to Kelvin? Add 273. And this is step number 1. Please don't forget it. Don't forget to add 273 to get the temperature. خلاص. I have T1, I have V1, and I have V2. I want the T2 very easily. طيب, يا Miss Noah, when I get the answer, it will be with Kelvin. Of course, it will be with Kelvin, but in the question, they are asking for Celsius. So, what I have to do is just after you got the answer with Kelvin, you gonna minus. Okay, you gonna minus 273. Nobody will see Celsius and say, yalla khalas, I'm gonna use Celsius in the formula. No, it will be wrong. It is not the correct way to answer it. We have to take it three steps. First step, convert into Kelvin, and then calculate using the formula, using the Charles law, and then again convert from Kelvin to Celsius. 3 steps, please. Okay. So this is very important. Type. And then the challenging question I will answer it also because here they said the volume is reduced by 45 degree. يعني I have V1, this is V1. I have T1, and thanks God they gave me already in Kelvin. I don't have to convert, thanks God, thank you. And the V2 is reduced. How to calculate if it is reduced? Minus. This is how I calculate it. It should be minus V2 equal to the original volume, this one, minus the original volume multiplied by 0.45. Why? Why 0.45? Because they said it reduced, يعني decreased by 45%. Means you will minus 0.45 because you have to change from percentage to decimal. خلاص? This is V2. And then V1 over T1 equal to V2 over T2 easily. We have V1, we have T1, we have V2, only one unknown. Simple calculation using the cross multiplication to calculate it. That's very easy, and the answer will be with Kelvin. Okay? طيب Gay-Lussac law. Gay-Lussac law will have the same idea, which is they gave you the question with Celsius, and you have to change it to Kelvin. How? Yes, by adding 273. Okay, they gave me P1 1.88. They gave me the first temperature. Yes. And I converted to Kelvin. They said the temperature increased, okay, and they gave me the new temperature also by Celsius, as I have also to convert it to Kelvin. So I have P1, T1, and T2, but P2 is unknown. خلاص, easy. Just substitute. يبقى how to answer Bowles, Charles, Gay-Lussac, and also combined gas law, what we have to do? First of all, put the formula. Second, substitute with the number, and then rearrange. If you want to rearrange, then substitute. It's up to you. Cross multiplication. This multiplied by this, divided by this to get this. Easy. And a piece of cake. But the trick is you should use temperature with Kelvin. This is the first trick. Second trick is if they're gonna say pressure increase or decrease, volume increase or decrease, you have to calculate. How? By, if it is increase, يبقى you're gonna add. If it is decrease, يبقى you're gonna subtract. The initial pressure or volume, whatever, plus or minus, accordingly increase or decrease, the initial temperature multiplied by the percentage. This is the only tricks in this part. I hope, inshallah, you're gonna answer them all correctly. Type. Let's take one example from the combined gas because all of this part have the same idea exactly. Let's take question number 11. A sample of air exerts a pressure. This is the pressure. And at temperature, oh, I can see Celsius. I have to convert. Perfect. And the syringe is placed in a boiling water at 100 Celsius degree. The pressure is increased. The pressure is increased. So this is P2. And 100 also degrees Celsius I have to convert. Perfect. I have pressure, I have temperature, I have temperature, I have pressure. And they said that the volume 2, because they said which reduce the volume into 0.224 milliliters. So this is the second volume. What was the initial volume? Volume 1, we don't know. Okay? Volume 1 is unknown. Type. How to answer it? But our formula for combined gas, which is P1 V1 over T1 equal to P2 V2 over T2. And then what we're gonna do, just fill in our formula. Fill What is B1? Yes, this is B1. What is V1? Unknown. Divided by T1? Yes, by Kelvin. This is T1. Okay, equal to B2. Where is B2? This is B2. Where is V2? This is V2. Where is T2? This is B. You just fill. Substitute the number. خلاص, easy. And then cross multiplication, it will be 1.02 times V1 multiplied by 373 equals to, in the other side, 1.23 times 0.224 times 295. This is after the cross multiplication. طب I want V1 alone. يلا substitute. So V1 will be equal all of this divided by this multiplied by this. طيب, girls and boys, pay attention. If you want to first rearrange and then substitute, طبعا it's completely correct. So it is according to your convenience, how you like to answer. For me, I prefer to substitute first. I like dealing with numbers more than simple. That is for me. Numbers for me is easier than simple. But it's up to you. If you want first to rearrange, يعني you're gonna say P1 V1 over T1 equal to P2 V2 over T2, and you want V1 alone, صح? So V1 alone will be P2 V2 T1 over T2 P1. Okay, يعني you arrange first and then substitute. It's completely up to you. Okay, but again, for me, I find dealing with number easier than simple. Other students may say, la, this is easier for me. It's completely up to you. Both will give the same answer, and طبعا the answer will have the same unit, which is milliliter. Get it from the calculator. Okay. طيب, the last question, the last part is the, okay, we didn't get it yet. Okay, let's revise this part from the book. So we answered Bowell's law questions, and Bowell's law represent the pressure and volume and in a constant temperature. And we answered Charles' law questions. We answered also Gay-Lussac law questions. We reached till the combined gas law, and we answered also its question. This is okay. This summary is very important. So this summary is very important. I explained it, but please go through it again because it is very important. تمام؟ Okay. تمام. Ideal gas law. Avogadro's principle and the molar mass. Avogadro's principle, that means there is equal number of particles for all sample of gases under the same temperature and under the same pressure, regardless the size of the particle itself. So the number of particles will be equal. And molar volume says that there is a certain volume that the gas fill under certain temperature, which is 0 Celsius degree and 1 atmospheric pressure, and this is what we call the standard temperature and the pressure, 0 Celsius and 100 and 1 as the atmospheric pressure. This is called standard temperature and pressure. Type. Under this standard temperature and the pressure, the volume occupied by 1 mole is 22.4 liter, regardless the size of the gas particles. Regardless the size of the gas particle, regardless it is light gas ولا heavy gas ولا whatever, it will occupy 22.4 liter under standard temperature and pressure. Okay, this information can be easily come as question from 20 to 25. Okay, all of these kind of question, let's go to start to answer it. All of this kind of question is the same idea. What is this idea? You're gonna put 1 mole occupy 22.4 type, and then read the question. يبقى whenever you see standard temperature and pressure على طول 1 mole occupy 22.4 liter على طول. Okay, how much carbon dioxide gas in a gram is in 1 liter of balloon? طيب يبقى I gonna say 1 mole occupy 22.4. So how many mole will occupy 1 liter? And then I will make a cross multiplication. So the number of mole will be, this is question number 21, okay? Will be 0.045, which is coming from 1 liter times 1 mole divided by 22.4. Okay, so it is 0.045 mole. Type. The question doesn't ask about mole. The question is asking about carbon dioxide in a gram. Carbon dioxide in gram. I know well this pyramid, this lovely pyramid, and we're gonna use it all this term, which is the number of mole equal to mass in gram divided by molar mass. Type, I have the number of mole. Molar mass easily we can get it from the periodic table. So the mass in gram will be equal to the number of mole, we got it, multiply by 44, which is the molar mass, I got it from the periodic table, carbon dioxide. This is how to calculate it in gram. So this is how to answer question 22. Okay? Ideal gas law. Ideal gas law taking consideration 4 variables: pressure, volume, temperature, and number of mole or number of particles. Type. طبعا we know that pressure, volume, and temperature, we know the relationship between them. What about the number of particles or number of mole? What do you think? By increasing the number of particles, the pressure will be increased or no? Yes, it will be طبعا increased definitely. Type. So the relationship between pressure and number of mole or number of particle is directly proportional. So it will be arranged like this, which is equal to R constant. This is a constant number. I can rearrange it into straight line like this. So it will be BV cross multiplication equal to nRT, which R is a constant. R is a constant, but it has different values. R is a constant, but it has different values. These are the values. These are the values. So what the values different according to what? Volume liter. خلاص. Temperature we said it should be Kelvin. خلاص. Number of mole, خلاص, particles mole. So the only variable or the only things will change is the unit of pressure. So according to the unit of pressure, the constant will be changed. يبقى I have constant value if I use atmospheric pressure, another constant value if there is kilopascal pressure, and another value if I gonna use millimeter mercury. Different values of R, and we're gonna use it to answer these questions. Let us go to answer these questions in your book. Okay, let's start with question 26. Celsius temperature. Put in your mind that after you got the Kelvin degree, you have to convert to Celsius. How? Minus 273. Okay. طيب. Contains 1 liter, يبقى that is the volume. Pressure 143 kilopascal, that is the pressure. And the number of mole is mentioned, which is 2.49 mole. خلاص. I'm gonna use simple formula for ideal gas law. This is the ideal gas law. I have P, I have V, I have N. R, I got it from the table, and I'm gonna use 8.314. Why? Why 8? Where it is? Yes. Why 8.314? Because they said the pressure by kilopascal. So this is the unit they gave it to me in the question. But I'm gonna use 8.314. Okay. Okay. So the temperature. So simply you're gonna rearrange and get the temperature. It will be 6.9 Kelvin. Type. After calculating 6.9 Kelvin, you have to say minus 273 to calculate it in Celsius and see the answer how much it will be. تمام? Okay. So that is the ideal gas law. طيب, let us go to how to calculate the molar mass and density. طيب. طبعا, don't forget my pretty pyramids, which is number of mole equal to mass divided by molar mass, and density equal to mass divided by volume. These two formulas. Okay. My ideal gas law is BV equal to nRT. BV equal to nRT, but I know from this pyramid that N equal to mass divided by molar mass. So I'm gonna replace N by adding mass divided by molar mass. Mass divided by molar mass and multiply R exactly T, خلاص, it will be nothing changed. Let's rearrange it in a straight line, cross multiplication. So BVM equal to M, this M is the molar mass, and this M is the mass alone in gram. Okay? طبعا this R is a constant, and this T is the temperature in Kelvin. طبعا V volume, P pressure. Okay, I want M alone. خلاص, M alone equal to MRT divided by BV. That is how to calculate the molar mass. And the question will be very direct. You will just substitute in the formula. Type. From this pyramid, I know that M divided by V equal to D. So I can replace it by putting D and then complete RT divided by B. Yani you will complete the formula. You will just put D instead of the M and V. Type. Let's do them in a straight line. Cross multiplication. It will be MB, this come together, MB divided by DRT. I want D alone in a side, so density will be equal to MB over RT. This is two formula. If they're gonna ask about it, it will be direct. But you have to know what is each symbol. M capital molar mass. B pressure. D density. R constant, T temperature with Kelvin. You have to know the symbol, but it is very easy and you will just substitute by numbers. Type. Ideal gas law means the gases are ideal. يعني the gases behave in ideal way. To be honest, nothing is like this. يعني, for example, no one of you is ideal student. We hope to be ideal. I hope to be ideal person. I hope to be يعني perfect. We all try, but nothing is ideal. Ideal gas says that the volume for the particles is very small. The particles move randomly, and the forces of attraction between particles almost very weak, almost no attraction force. The particles fill the containers. يعني that is the ideal. But what is realistic? Sometimes the gas is not behaving like ideal gases. When this happens in large particle size, if the gas has large particles, why? Because it says أصلا number one that the volume of the particle is very small, فلا يعني the particle here is large. Polar gases. If there is polar gases, so it will be kind of force of attraction between molecules. صح ولا لا? So this is against the ideal gas. طيب, in high pressure, the particles will be closer to each other. And we said that the volume will decrease, يعني the particles will be closer to each other, which also against the ideal gas. In low temperature, there is low kinetic energy, so low movement, which is also against the ideal gas. So they can ask you when the gases behave not like the ideal gas: in low temperature, in high pressure, in polarity, and in large particle gases. طيب, Alhamdulillah, I think we have finished unit number 2. This is molarity, this is density, how I explained them. خلاص, we have finished. Okay. Oh, this is also, you have to read it. Okay, that's about polarity and the size of particle, how they are behaving not like ideal gas. This is the last thing, and gas stoichiometry not with us, you know that. So خلاص, we have finished this unit. Let's go, Bismillah ar-Rahman ar-Rahim, to the last unit, which is mixture and solution. طيب. Mixture and solution. You have to know first, and we have different types of mixture. You know from grade 7 and 8 that we have two types of mixture, which is heterogeneous mixture and homogeneous mixture. Heterogeneous mixture, where they are not completely blended and you can see the particles of the mixture. Like in homogeneous mixture, when they are completely blended together. That is what we studied before in grade 7, 8, and so on. But today, you're gonna know another two types of heterogeneous mixture, which they are suspension and collision. And what is the difference between suspension and collision? I prepared this for you, which contains the difference between solution, suspension, and أنا أسفة, I said collision. I don't mean collision, I mean collide. أنا أسفة, I mean collide. So this table represents the comparison between solution, suspension, and colloid. Okay, the solution, homogeneous mixture, and we're going to speak in details about solution. Suspension and colloid, heterogeneous mixture. So collision, أنا أسفة, again collision, colloid. So colloid and suspension, heterogeneous mixture, and solution, homogeneous mixture. Okay. Okay. As suspension and colloid both are heterogeneous, why they are different? According to the size of the particles. Suspension has large size of particle. Colloid, medium size of particle. طب what is the difference? The difference is you're gonna see it in a cup of milk and a cup of sandy water. In sandy water, you can just leave it. It will settle out, or it will settle down, or it will make sedimentation down. So we can separate it by filtration or settling out. Why? Because the particles are big, large, so it is easy to separate it. That is mud. What about colloid? No. Colloid, you cannot separate them by settling out or by filtration because the particles are medium size, from 1 to 1000 nanometer. Okay? So although they are heterogeneous mixture, but they are different in this. طب what makes the colloid stay in its appearance and don't be separated like the suspension مثلا? We all know where it is. We all know if we put a muddy water after hours, it will be clear like this because of the settling out and suspension. We all know this. تمام؟ طيب. But why in colloid this doesn't happen? This doesn't happen because of two things. Number one, electrostatic layer. What is the electrostatic layer? There is dispersion media. Okay. And there is dispersed particles. Also okay. This dispersion media contains ions, positive and negative. This dispersed media particles also has positive and negative. Actually, to be honest, all the atom is made of proton, positive, electron, negative, and even in static electricity, even if the insulator is not charged, even by rubbing and by friction, some electrons move and travel. This kind of movement of electrons due to rubbing and friction, this will make ions to appear positively and negatively. Anyway, this part is يعني a little bit advanced. You have just to know that there is electrostatic layers. There is attraction force between positive and negative, يعني different or unlike charges attract, and there is repulsion force between same or like charges, which is positive and positive or negative and negative repel. This attraction and repulsion is kind of force. This is called electrostatic force. This is called electrostatic force. This electrostatic layers or electrostatic force, this electrostatic layers in the dispersion media prevent the particle or the dispersed particle from settling down or from settling out. Okay? But how to make it separated and separate this mixture and make the particles separate away from the dispersed media? By breaking this electrostatic layer. How? By adding electrolyte to the solution, to the colloid. By adding electrolyte, by adding ionic, like how we make a cheese, we put vinegar with the milk. Vinegar طبعا is highly ionic, it has ions, صح ولا لا? It is acidic. by destroying this electrostatic layer. طيب. Also heating help to destroy this electrostatic layer. This is one reason why the colloid stay in its appearance and don't move. This is one reason, but the other reason is the Brownian motion. What is Brownian motion? Brownian motion means the particles are keep on motion randomly, and they disperse in the dispersion media, keep on colliding with the particles of the dispersion media and keep on moving and colliding and moving and colliding. This helps also to prevent the settling out of the colloid. خلاص. So two reasons, which is electrostatic layer and the Brownian motion. There is keywords called sexotropic. Sexotropic means it is solid, but by squeezing it, it's gonna change to liquid, and you're gonna see it in the toothpaste. طيب. Tyndall effect. Tyndall effect is, this is with you, and the question we're gonna answer it now. In unit 1 and 2, gas and gas law, Graham's law, Dalton gas law, Powell's, Charles, Gay-Lussac combined all of this part. I answered that question in the book because it cover all the ideas. But in this unit, I gonna inshallah answer with you some question from previous exam. I already prepared for you. Okay. Type Tyndall effect is scattering of light when it passes through colloid. Yani, we all know that the light move in straight lines, and it's gonna pass through media, different media like glass, like water. So if there is a beaker contains water, suppose that the light pass in a straight line. Yes, it will refract, but it will pass. But if this water contains milk, yani it made colloid, so the light will scatter, not, yani you can see this kind is not passing straight, it is scattering. This is called Tyndall effect, and we gonna use it as test to test the purity of water, because if only 1 drop or 2 drops of milk fall in this beaker, it will appear clear water, yani it will be clean beaker and water. But by this test, you're gonna see the light is scattering, means it is colloid. Type. Let's speak about solution, homogeneous mixture or solution. There is a table. This table you have to memorize, but if you'll try to memorize it like this, it will be yani a little bit hard for you. I will give you a very simple way to memorize it. First of all, you have to know that solution is simply we have beaker, we have solvent, and this solvent we're gonna add solute. Dissolving solute in solvent make a solution. يبقى solution made of solute will be dissolved in a solvent. Solvent is the media. Solute is what is added to this. Okay? Type. We know that we have 3 states of matter: solid, liquid, and gas. If we're gonna say that these are the solvent, يبقى I have solid, liquid, and gas solvent. Type. If, let's start with the solid. If solid added to solid to be dissolved in it, it will be steel. It will be steel. Okay. If liquid added to solid, like mercury added to silver, it will be the dental amalgam that the dentist use for your teeth. Type. خلاص. So we have 2 examples for solid. Type. If the solvent is liquid, in liquid I have 3 options. If salt, which is solid, added to liquid, that will be ocean water. If liquid added to liquid, that will be vinegar added to water. If gas added to liquid, that will be carbonated water, or the soda that we drink. All of it is carbon dioxide dissolved in liquid. Type. The last one is gas. If the solvent is gas, and gas dissolved in gas, which is the mixture of air that we breathe. So whenever you see this table, it might be hard, and you say, oh, I will memorize all of this. But if you do it in this way, it will be very easy for you to memorize. So this table is in your EOT, so you have to memorize, inshallah. Type. Forming solution, we said that we have solute, dissolve in solvent. If it dissolved, that means it is soluble. Soluble like salt, soluble like sugar, it dissolves in the water. Okay? طيب, would I add sand? It doesn't dissolve. That means it is insoluble. It is insoluble. It doesn't dissolve. It doesn't get solution, so it is insoluble. طيب, if liquid and liquid, oil and vinegar and water, we're going to say it is miscible. Water and vinegar, that is miscible. They are miscible together. طب oil and water, لا, they are immiscible. They are immiscible. They will not make a solution together because they will be separated into different layers, layer of oil and layer of water. They are immiscible. تمام. This is the first lesson. This is the first lesson, and this is soluble, this is insoluble, this is miscible, and this is immiscible. Right, this is the first lesson. Second lesson is the solution concentration. And how to calculate the solution concentration? We calculate the solution concentration through these formulas. Percent mass, percent volume, molarity, molality, and mole fraction. يبقى we have 5 formulas to calculate the concentration of the solution. يلا بسم الله بسم الله. I'm gonna explain each one and take one example from each one. By doing this, yes, I'm gonna explain each formula and taking one example from each formula, and by doing this we're gonna reach to last lesson inshallah. Where's the last lesson? This one, factor affecting solvation. خلاص. So let's inshallah go and start to answer this question. Okay, so concentration of ratio, we're gonna explain it, or we're gonna use 5 different formula. The first formula is percent by mass, percent. So it is mass of solute divided by mass of solution times 100 because it is percent. But the trick here, tips, exam tips, the trick here is when I say solution means solvent plus solute. Solvent plus solute. يبقى what is the percent by mass of sodium bicarbonate? Sodium bicarbonate in a solution contains 20 grams of sodium bicarbonate dissolved in 600 milliliter water. One of the students can say, oh, very easy, 20 divided by 600, full mark. No, not full mark, 0. Why 0? Because when they say percent mass, which is equal to mass of solute divided by mass of solution times 100, mass of solution means solvent plus solute, both of them. يبقى it will be 20, yes, divided by 620, which is, this is 20 plus this 600. طبعا times A times 100, and you get from the calculator the answer. Okay, so this is the trick. It is very important. خلاص. يبقى the trick, if they say solution, you have to add solvent plus solution. طيب, question number 10. You have 1,500 grams of what? Of bleach solution. The percent by mass of the solute sodium hypochlorite is 3.62%. يبقى here they give you the percent. Okay, how many grams? Type easy. I know the mass of the solution, which is 1,500. They gave it to me. تمام. and I know the percent by mass 3.62. طيب what is the mass of sodium hypochlorite؟ خلاص this is mass of solute divided by this, it will give this, but pay attention, it is percent. يبقى I told you at the beginning of this video, whenever you see percent, convert it to decimal. So it will be 3.62 divided by 100 to convert to decimal. Or يعني you can use this way, divide by 100, or you can على طول say it is 0.0362. Both of them is correct. Okay? Then by multiplying, this will be the solute, which is 54.3 gram. خلاص. I calculate the solute by gram. Look at the other question. The other question says how many grams of solvent are in the solution. How many grams of solvent are in the solution. طب I have the total and I have the solute. Easy, you will just subtract. يبقى the total minus the solute to get how much is the solvent. طيب, let's go to the challenging question. What is the challenging question? The percent by mass of calcium chloride is 2.65%. Okay. If 50 gram of calcium chloride is used, what is the mass of the solution? طيب, they give me the percent by mass and they give you the mass of the solute and they want the mass of the solution. طب very easy. Very easy. You have to just rearrange and don't forget that this percent means this number divided by 100. يبقى you have to convert it to decimal. And it will be 50 divided by 0.0265 and it is equal to this number by gram. تمام؟ طيب. I want to make check if my answer is correct or no. طب okay, make check. This is 50, it is in the question or itself, and is divided by the total. It is divided by the total solution. So this solute divided by the total solution multiply by 100. Yes, it is the same number they gave me in the question. خلاص, 100% I am correct. 100% I answered correct. So in this kind of question, two tips for the exam. Solution means solvent plus solute, both of them. Number two, if you have percent, change it to decimal by divided by 100. Type. This is the first way, اللي هو how to calculate the concentration of solution using mass. Second learning objective is how to calculate the concentration using percent volume. It is exactly the same, You're gonna say that percent volume equal to volume of solute divided by the total volume multiplied by 100. Exactly the same. يبقى you will just do do simple calculation. طيب. Number 13 easy. You will just put the number 35 and then you're gonna add 135 plus 35 because that is the water and the ethanol, so solute plus solvent. فخلاص, multiply by 100 and get the answer. That is easy. But number 14, they give you the volume of isopropyl alcohol 24 milli and the water 1.1 liter. I cannot add liter with milli. I cannot. It will be wrong. يبقى first I have to convert from liter to milli by multiplying by 1000. Then now I have milliliter and milliliter, then I can add. خلاص. After you add them, you can just put them in the formula and get the percent by volume. يبقى this is another tip This is another tip. You have to convert so the units will be the same. Okay? Type question 15, which is challenging, and again it is same idea. 18 milliliter of methanol is used to make an aqueous solution of 15% methanol by volume. خلاص يبقى I have the volume of solute and I have the percent volume. I will change it to decimal because I know this means 15 divided by 100. Okay, so I gonna cross multiply and rearrange my formula to get x, which is the volume of solution, the total. خلاص, just using the calculator to calculate it. يبقى we took two examples for calculating concentration of solution. The first one percent mass and the second one percent volume. We fill this learning objective. The other learning objective is the molarity. How to calculate the molarity? Molarity equal to how to calculate the molarity? It is the mole of solute divided by liter of solution. يبقى how to calculate molarity? What is the formula? It is mole of solute divided by liter of solution. يبقى solution should be liter and mole of solute. Okay. Type. The trick here, they will not give you the mole direct. No, they're gonna give you gram. Type, okay, I know how to convert from gram to mole. I know very well this. Okay, because I know this triangle in which the number of mole equal to mass in gram divided by molar mass. Molar mass, I can get it from the periodic table. Molar mass of glucose is 180. I got it from the periodic table. Okay, so molarity will be equal to mole of glucose divided by liter of solution. They gave me 40 gram of glucose. يبقى number one, I have to calculate mole of glucose, which is 40 divided by 180. And this is the number of mole. خلاص, you have number of mole, you have 1.5 liter. Don't convert, use liter as it is because in the formula there is liter. And it will be done, and it is the 0.15 molar concentration. Okay, this is number 16. Let's go to number 17. They said that calculate the molarity of 1.6 liter. Okay, of solution containing 1.55 gram of dissolved KBr, potassium bromide. Okay, what is the problem? طبعا I have to know the molar mass of the potassium bromide from the periodic table, and then I have to calculate number mole, how many mole, by dividing 1.55 divided by the molar mass, because you know we talk last term in how to calculate number of mole. Multiply 1.55, this is the gram given in the question, multiply by 1 mole over the molar mass for it. Molar mass for it, whatever, how much it will be, we can get it from the periodic table. Potassium how much and bromide how much, and we're gonna add the number here. خلاص, this number of mole, when you get it, you will divide it by 1.6 liter, and then this is the final answer. Okay, all the question have the same idea except 19 has يعني a little bit trick. So let me go to question 19. Question 19 says how much calcium hydroxide, okay, this one, in a gram, okay, is needed to produce 1.5 liter of 0.25 mole solution. يبقى calcium hydroxide in gram is needed to produce 1.5 liter of 0.25 molar concentration. طيب يبقى the required is the mass in gram. 1.5 liter of solution, this is I have it, okay, and the molarity is 0.25. This is they gave me in the question. طيب by using these two information I can calculate number of mole of calcium hydroxide, because the molarity equal to the number of mole of calcium hydroxide divided by liter of solution. So this molarity and liter is 1.5. I can calculate X easily, cross multiplication. So X, which is the mole of calcium hydroxide, equal to 1.5, which is the liter of solution, multiply the 0.25, which is the molarity. Okay, and this is my answer. يبقى this is 0.38 mole is the how many mole of calcium hydroxide. But the question doesn't want mole. The question wants mass in gram. طب how to calculate mass in gram? We're gonna say number of mole equal to mass in gram divided by molar mass. يبقى I have the number of mole. From the periodic table I can get the molar mass. So mass in gram will be, you just multiply the number of mole, which is 0.38, multiply by 74.08, طبعا divided by 1 mole, or you don't divide, whatever. This is the conversion factor. We took it last term. Equal to 28 gram. From where I got 74? From the molar mass from the periodic table by going back calcium, oxygen, hydroxide, hydrogen, 1 times 40 because the calcium is 40, 2 times 16 because the oxygen is 16, 2 times 1 because the hydrogen is 1, and then you're gonna add them together. It will be 74.08. تمام? So this is one of the tricky question, and it's very, very nice question. I really like it. I really like it. Okay. Again, let's revise together. Let's revise together. We answered, Bismillah ar-Rahman ar-Rahim. We took examples. All of this, mashallah, we are going forward in the syllabus. But I want, yes, we, alhamdulillah, we answered percent by mass, mass of solute divided by mass of solution, and pay attention, mass of solution means the solvent plus the solute. Number 2, we answered percent by volume, which is volume of solute divided by volume of solution, and again solution means solvent and solute. We answered molarity, and it is equal to mole of solution divided by liter of solution. The tricky here is they're gonna ask you to get يعني the mole from the mass in gram, or to get the mass in gram from the mole. This is one trick. The other trick is they give you percentage, and you know, by giving percentage you have to divide by 100 to be decimal. طيب, let's take example for molarity and mole fraction. First, molality. Molality. What is molality? Molality means mole of solute divided by kilogram of solvent. Mole of solute divided by kilogram of solvent. This is molality. خلاص? This is molality. طيب, mole fraction equal to mole of solute divided by mole of solute plus mole of solvent. خلاص? Do you know these two? Let me take it copy paste, because I'm gonna answer question 27, 28, 29 and 30, and then go direct to to the last lesson. Okay. Okay, keep the formula beside us and then start to answer. Type. The first question, what is the molality? Molality, okay? So I'm gonna use this formula, okay? Not molarity. Molarity with R, this formula, which is mole divided by liter of solution. لكن هنا molality, mole divided by kilogram of solvent. Okay. What is the molality of solution contains 10 gram? They give me the gram. يبقى I have to calculate the mole. That is number 1. Dissolved in 1000 gram. That is number 2. I have to convert from gram to kilogram. It is kilogram. It should be kilogram. خلاص؟ يبقى it should be kilogram. So mole of solute, which is I gonna get it by this pyramid, number of mole equal to mass divided by molar mass. So this is the number of mole of sodium sulfate. Okay. Mass, which is 10 divided by the molar mass, it gets me this number. And the molality equal to this number divided by 1. Why 1? Why 1? Because 1000 gram divided by 1000 equal to 1 kilogram. يبقى 1000 gram equal to 1 kilogram. تمام? This is the molality and the unit is m small. طيب. Question 28. How much barium hydroxide in a gram is needed to make 1 molality aqueous solution? 1 m equal to 1 mole over 1 kilogram. Simple, simple. الماس المول I have is 1. طيب. If you have the mole 1, يعني the number of mole here 1. I want the mass in gram, which I don't know, and the molar mass of this barium hydroxide after calculating it is 171. يبقى simply what you have to do, it is barium hydroxide, right? Yes, it is barium hydroxide. So simply you will just multiply 1 times 171 gram. Okay. Question 29, another formula, which is mole fraction. How to calculate the mole fraction? This is how to calculate the mole fraction. It is, let me use the highlighter. It is the mole fraction equal to mole of solute divided by mole of solute plus mole of solvent. And please don't forget to use a bracket in the calculator. Type. What is the mole fraction of sodium hydroxide in aqueous solution that contains 22.8%? Okay, 22.8 sodium hydroxide. يبقى الwater will be 100 minus 22.8. Simple. Simple. If all of them is 100, if you draw a pie chart, so this is the sodium hydroxide and all of this is the water. Simply. صح? So it will be 77.2% mass. But the question doesn't ask about the percent mass. It is asking about the mole of fraction. Okay. يبقى I have to get the mole of fraction. The mole of sodium hydroxide divide and the mole of water. How? By using this formula. Mass divided by molar mass. Number of mole. Mass, which is 22.8 divided by molar mass of sodium hydroxide, which is 40. يعني multiply by the conversion factor اللي هي 1 mole divided by 40. 40 again comes from the periodic table. Okay, so sodium hydroxide will be 0.57 mole. 0.57 mole. This is the number of mole of sodium hydroxide. Same exactly you're gonna do for water اللي هي number of mole equal to mass in gram اللي هي 77.2 divided by 18. I'm writing it here. No, I didn't write. Okay, divided by 18, so the answer will be 4.28. يبقى exactly the same way اللي هي number of mole equal to mass in gram divided by molar mass. Mass in gram of water was 77.2 divided by molar mass اللي هو 18, so that will be the answer. خلاص, I have the mole of sodium hydroxide, I have the mole of the water, and then just use the fractional mole fraction, which is mole of solute divided by mole of solute plus mole of solvent. يبقى the trick in into you have to calculate the mole. They will not give you the mole directly. You will not give the mole. The question will not give you the mole directly. You have to calculate the number of moles. How? You know the conversion factor. We took it last term, and the molar mass will be given in the exam, but here I show you again, for many times in this video I show you how to calculate the molar mass just in case, but I'm sure it will be given in the exam. So sodium hydroxide NaOH يبقى 1 times 23, because if you go to the periodic table it will be 23, oxygen 16, hydrogen 1, so it is 40. Mass divided by 40 to calculate the number of mole. I hope that my words are clear, and I hope I give you a clear understanding for this part. Last question is really tricky, so let us read it and then explain it. They said that, let us read it. This is one challenging question, okay? What are they saying? If the mole fraction of sulfuric acid, okay, is or in aqueous solution, يعني there is water, okay, is 0.325. What is the percent by mass? Percent by mass. طيب. What I know is I have total solution. In this solution, I have water and I have sulfuric acid, H2SO4. The sulfuric acid is 0.325, and the water I don't know, but I know that both of them is making one whole. But I can say 1 minus 0.325, so the number of mole of water will be 0.675. يبقى from knowing the mole of fraction, I can know the mole of water and the mole of sulfuric acid. خلاص. Done. What done? Yes. You know the mole? Yes. From molar mass, you can get it from the periodic table? Yes. يبقى easily you can calculate the mass in gram. Mass in gram equal to the number of mole multiplied by the molar mass from the periodic table, and then this is the mass in gram of sulfuric acid. Do the same for the water. That is the number of mole, that is the molar mass. This is the mass of water. Now you have mass in gram of water and mass in gram of sulfuric acid. Just put them to get the percent mass, which is mass of solute divided by total mass of solution, which is both of them together. طبعا multiply by 100 because we want to calculate percentage. So do it with your calculator. You're gonna find the same answer, but don't forget please to add the bracket here. Okay, let us go to see the last lesson, which is factor affecting solvation. By the way, this is pie chart. يعني from this pie chart you can know that 22 HCl, the fraction mole is 22. يعني HCl divided by the total, it is a 22. Both of them will make 100. Okay. Okay, solvation happens because the solute, which is we always say like dissolves like. يعني polar solvent dissolve ionic or polar compound. Why? Because polar solvent contains positive and negative, and polar compound, let's say sodium chloride, will have sodium Na positive and chlorine, which is Cl minus. So separating positive and negative from each other, and the water is already polar, so it will make attraction force between the charges of the solute and the polar molecule of the solvent. This attraction force, if it is higher than the attraction force between the charges in the solute itself, it will dissolve. يعني the attraction force between the solute charges and with the polarity or polar of the solvent, this should be more than the solute and each other. تمام? This is how they dissolve, and this is how they distribute, because H2O, we know the H2O is O oxygen high electronegativity particles, so it will make partially negative, and hydrogen will be partially positive. So they were gonna arrange surrounding chlorine, which is negative, like this. يعني the hydrogen will be surrounding the chlorine, which is negative. In the other side, the other arrangement of the water will be from negative, partially negative, will be surrounding the positively sodium, like this. This will make it dissolve. This will make the solute dissolve. طيب. This is if it is ionic compound. يعني ionic compound, يعني there is positive, there is negative, because there is completely transfer of electrons, and one atom gained electron become positive, negative, and the other atom lose electron become positive. خلاص, positive and negative, like sodium chloride. What about covalent bond? There is like sucrose, it also dissolves in water, but there is no ionic bond, it is all covalent bond. Okay, but still it is polar, because also there is oxygen, and oxygen is high electronegativity atom. Electronegativity means it can attract the electrons towards it. Attracting it meaning make partially negative charge, and the hydrogen will have partially positively charged, so it will make hydrogen bond with water. Making this hydrogen bond with water make it dissolve. تمام؟ طيب. I have many questions now we're gonna go and answer it, some questions from previous exams. طبعا this is important, the solubility as a function of temperature. This you have to know. I'm gonna explain within the questions now. Something just last part, which is Henry's law. Henry's law describes solubility of gas. Solubility of gas is easy, you can describe it. If you open a can of Pepsi, so you're gonna see the carbon dioxide going out. Why? Because you decrease the pressure, so you decrease the solubility of carbon dioxide, so it will go out as a gas. So there is a relationship between solubility and pressure, directly proportional relationship, and this is called Henry's law. So solubility and pressure are directly proportional. Increasing pressure, increasing solubility, and the opposite. طيب, this is Henry's law, And we have here some examples. Let's go and answer it, and this will be the last thing I'm going to answer with you the questions. Previous exam question. Don't go anywhere, just wait with me. Question number 36. If you have 0.55 gram of gas dissolved in 1 liter of water, يبقى I have S1, I have P1 dissolved in 1 liter of water at 20 kilopascal P1. How much dissolved يعني S2 is unknown at 110 kilopascal يعني B2 I have P2. خلاص, just put the formula, rearrange the formula, substitute the formula, get the final answer, and طبعا the answer will be gram per liter. Okay, question number 38, which is challenging. The solubility of the gas is 7 atmospheric, okay, of pressure, okay, is 0.52 gram per liter. Okay, if I have S1, I have P1. Okay, how many grams, okay, of a gas would be dissolved in 1 liter if the pressure increase? Again, they mention increase and decrease. يبقى I gonna add, يبقى plus. Plus what? The initial pressure, which is 7, plus 40%, which is 7 multiply by 0.4. ليه? Because this 40% I gonna change it to decimal. It means 40 divided by 100, which is 0.4. خلاص? So 7 the initial pressure plus 7 multiply by 0.4, this is between brackets, this is the pressure number 2, and طبعا it should be increased, يبقى it should be high number. خلاص, you have P1, you have P2, you have S1, S2 is unknown, just simple rearrangement of the formula, and the result will be 0.73 gram per liter. Okay, thank you very much. Now we have finished the 3 units, but stay with me, don't go anywhere. I want to answer with you some of the previous questions, exam questions, okay? طبعا here are some examples. You can pause the video and see some examples of solution. The first row is solution, the second row is suspension, and the third row is collide. You can pause the video and see the examples. Okay, anyway, let's read the first question. Why does the light appearance a scattering when it falls on mixture 1? Yes, mixture 1, and it is not scattered in mixture 2 simply because 1 is colloid and 2 is not. Yes, 1 is colloid which scatter the light. Scatter the light correct, absorb غلط. تمام? So it is important. Type. The second question. Which destroy the colloid? طبعا they give you heating and they give you stirring electrolyte, adding electrolyte 1 and 2. The answer will be 1 and 2 together. Heating and adding electrolyte to the colloid. Which one of the following solution has its solvent in solid phase? Type. Dental amalgam. ليه? Because we said that dental amalgam has solid phase, and the solute will be mercury in silver. Mercury dissolved in silver, يعني liquid in solid. طبعا الاير لا, air gas in gas. ocean water لا, ocean water solid in water. vinegar طبعا لا, liquid in liquid. يبقى all of these no, يبقى هي this is the only answer. طيب, next. Why do colloidal particles settle out in a mixture when it is heated? Because the heating will give enough kinetic energy to overcome the electrostatic force. I want to overcome this electrostatic force by heating or by adding electrolyte. تمام? What is the type of solution if the solute of carbon dioxide is in water, gas in liquid, carbon dioxide gas and water is liquid, so it is gas in liquid. This is the carbonated water or the soda. What is the solvent of air? Nitrogen, because that is the most abundant gas in air. Which one of the following solution has its solvent in solid? طبعا again it is the same question. Which of the following type of solution is represented by carbonated water? Again, solvent is water اللي هي liquid and solute is gas. Carbonated water is liquid solution, not solid. Solid in solid it is steel. Solid in solid it is steel. طيب liquid in liquid it is vinegar in water. تمام. Gas in gas it is the air. تمام. So these examples are important. These examples are important. Antifreeze also is liquid in liquid. تمام. طيب this is طبعا without reading the question it is suspension يعني. This is which of the following can be separated by allowing it sit for a period of time? Suspension, of course, because it will be the sedimentation will appear and the settling out, because the particles is large in size, not like the colloid. Two liquids mixed, if they are mixed يبقى miscible. No, they said it's not mixed. Can be mixed together but separate shortly. It is immiscible. It is immiscible. You have to read the question carefully. Immiscible, because they will be separated shortly. Like if they mix, it is and not separated, it will be miscible. So this question is immiscible. Immiscible. طيب, what is the suspension? طبعا muddy water. Milk لا. Milk is colloid. Dust in air لا. Butter لا. Concentration ratio, خلاص we answered ما شاء الله all the questions regarding this part. This is important. This is important. They can ask you to get from the graph. يعني هنا the answer is calcium chloride had the solubility of 64 at 10 degree. I don't have actually I don't see the question, but it is you go to 10 and rise up, so you have to know how to use the curve. يعني they can ask you, for example, what will be the solubility of sodium chloride at 60 degree. طب what we're gonna do? Let me zoom. Okay, this is zoom. This is sodium chloride and this is 60. يبقى I'm gonna go up, okay, and I'm gonna go here. It is 40 gram per 100 gram of water. يبقى you have to know how to use the line graph or the graph for this solubility as function of temperature. The x-axis is temperature and the y-axis is solubility. طيب. Which of the following substance has solubility decrease when the temperature increase? All of these, the solubility increase because the gradient is positive. Positive gradient, يعني it is going up, the solubility is increasing, except cesium sulfate. Cesium sulfate, the solubility is going down. So it is decreasing solubility by increasing the temperature. Look at this tricky question. They said that which in solvation process, which step number two, not number one. In number one, they gotta separate it into ions. In number two, the solute particles are surrounded by the solvent particle. يبقى the solute particles will be surrounded by the solvent particles. تمام؟ Okay. طبعا breaking bond between solute and making ions and this will take energy, so we called it a endothermic reaction. طيب so, surrounding solute will be surrounded by solvent and make attraction force and dipole force between them. This kind of doing more force, it is exothermic. يعني breaking the bond is endothermic and doing another bond is exothermic. The total reaction either it will give يعني exothermic energy or it is take energy يعني endothermic يعني it will be according to which one is greater. خلاص the difference between them. فمثلا if you put calcium chloride in a water to dissolve in a water and then you touch the beaker, you're gonna feel warm يعني ايه؟ يعني it is exothermic reaction, it gets out heat. لكن if you put ammonium nitrate in a water and it dissolve and you touch the beaker, you're gonna feel cold يعني ايه؟ يعني it is endothermic, it takes energy. خلاص. Why sugar sucrose dissolve in water while oil doesn't؟ طبعا because sucrose are non-polar لا، because oil form hydrogen bond لا، because oil form hydrogen bond أكيد لا، because sucrose are polar yes and oil are non-polar yes. Sodium chloride dissolve in water because water non-polar لا. Sodium chloride molecule no, molecule means it makes covalent bond لا. Water is polar yes and sodium chloride is ionic yes, so this is the answer. Which of the following solute more soluble can be dissolved? More soluble can be dissolved, you can add more, يبقى it is unsaturated because you still can add more, it still doesn't reach to the saturation. What is the reason that gypsum doesn't dissolve in water even though it is ionic? Yes, it is ionic, but it doesn't dissolve. Why? Because the attraction force between gypsum ion are very strong. It is more stronger than the gypsum and water. And we said the reaction, the attraction force between the solute and water should be more to dissolve. لكن هنا the gypsum ion attraction force is more stronger. That is why they made gypsum those who are يعني who can go to shower or swimming pool while they are wearing gyps in their broken legs because it will not dissolve in water. Like dissolve like طبعا polarity طبعا because we say that polar solvent dissolve polar solute and non-polar dissolve non-polar, so of course it describes polarity. Like dissolve like is used to طبعا solvation. Done. We have finished. Alhamdulillah, Alhamdulillah, and I hope that you got يعني you understand everything, and I hope in my explanation was clear. I hope that we answered all kind of question as much as we can. I tried to answer all the question in the book. So now you have a variety of ideas and you have everything. Thank you very much. Best of luck and my best wishes, and inshallah all of you will get high score. Thank you very much and meet you later inshallah. Thank you.